Justin Miller, Rockstar College Physics here. We're going to look at a few problems here involving going back and forth between unit vector notation and a vector expressed as a magnitude and a direction. So here's the problem. Alright, so conveniently I have some things written up here. So we're going to start off with this first problem that involves taking a vector, I'm going to call it A hat, and say that it is 7 at 65 degrees. Magnitude is 7, 65 degrees is direction, and we want to do this. Find A hat and B hat in unit vector notation. So let's just start with these two right here, shall we? We shall. All right, so we got ourselves, again, A hat is written in this form as the magnitude of A at theta sub A. So in this case, we've got A hat is equal to 7 at 60 degrees. Oh, 65 degrees. 65 degrees. We're going to assume 3 significant figures here. I don't want to get inundated with drawing out too many strenuous zeros, but this is what we've got. So we want to write this as A hat is equal to A sub x I hat plus A sub y j hat. That's what form that we want to write it in. So what do we need? We need the x component and the y component. How are we going to get it? That's right, we're going to go ahead and transform. So we know this. A sub x is equal to the magnitude of A times the cosine of theta sub A, and A sub y is equal to the magnitude of A times the sine of theta sub A. So we can go ahead and compute that out readily because we know the magnitude and we know the direction. Thus we've got ourselves this. A sub x is equal to 7 times the cosine of 65 degrees, and A sub y is equal to 7 times the sine of 65 degrees. Equals. Get ourselves a nice little calculator here. Make sure that we're in degrees. Pretty sure I am. Cosine 65 and sine 65. And we've got 2.958. Let's call that just 2.598, that's fine. And then 6.344. So this is what we get out of this. What do? Final step, write it in this form right here. That's the x component, there's the y component. We'll go ahead and take this to 3 significant figures and we can write ourselves that A hat is equal to 2.60 I hat plus 6.34 j hat. And there we go. We've taken it as a magnitude direction, written in unit vector notation. Let's go ahead and do it for this one right here. See if there's anything different about it. So now we've got that B hat is equal to the magnitude of B times the cosine, oh my gosh. The magnitude of B at theta sub B. So B hat is equal to 5 at 130 degrees. Again, we want to write that B hat is equal to some Bx I hat, its x component in I hat direction, plus By j hat, y component in the y direction. So we just proceed from there. Same sort of formalization that we had for A, we can do it for B. So we've got ourselves that B sub x is going to be equal to the magnitude of B, which is 5, times the cosine of theta sub B, which is 130 degrees, and B sub y is going to be equal to the magnitude of B, which is 5, times the sine of 130 degrees, and chop, chop, chop. 5 cosine 130, 5 sine 130, and I get negative 3.2139, negative 3.2139, and 3.8302. 3.8302. Take an extra significant figure. That's okay. We're going to round it off in the end anyway. We got the I hat and the j hat components. Notice something here. This is negative. What does that negative sign mean? How much is negative? No, we don't have negative how much. We have negative I hat. Negative signs with vectors is always directional. It doesn't, strictly speaking, go with the numeric value. Though it comes out in front of the numeric value, it's really about that component being in the opposite direction as, well, either just plus I hat or plus J hat. So in the end, we've got this. B hat is equal to negative 3.21 I hat plus 3.83 J hat. The X component is in the negative I hat direction, and the Y component is in the positive J hat direction. So in the end, we also want to go ahead and draw these two vectors out. So let me box this one up here. So we'll first take ourselves A hat. We'll just draw a nice little representation of it. Ourselves the X direction and the Y direction. And we've got the A with 7 at 65 degrees. We scale out the 7 and write approximately 65 degrees. Let's say that 65 degrees looks something like this. Close. We'll just say that this is it though. There's A hat. And then what do? Well, we have that its components are just translated perpendicular to one another, one on the x-axis and then one shifted over just in the y direction. So this is our a sub x I hat, our a sub y j hat. That's in the positive x direction, that's in the positive j direction, just like the components. Positive I hat, positive j hat. 2.6, 6.3. It should have been shifted up a little bit more, but that's okay. Hopefully you get the picture of that. Going to the next one, B hat we had was 5 at 130 degrees. So again, we've got ourselves Y and X here. 130 degrees, there's 90, ooh, there's 120, there's 130, somewhere around there. So let's just say 130 looks something like, it's almost in between, 130, something like that. We'll call that B hat right there. So now let's look at this. We'll begin, project this down, and then sweep over on the x-axis, and we've got ourselves B sub y, not A, it's B sub y j hat, and B sub x I hat. Here is our angle, theta sub b, 130 degrees relative to the positive x direction, 90, 130. And then we've got ourselves, the x component is in the negative x direction, which is negative I hat. Again, I hat says x direction, negative I hat says negative x direction. So 3.21 in the negative I hat direction, and 3.83 in the positive j hat direction. And there we go. We've got pictorial representations, we've got magnitudes, directions, and we've got unit vector notation as well. So I will say that it is important to draw these vectors out, especially in the beginning when you're getting used to things. Draw them out, make sure things match up. What you get in terms of the components and what you expect them to be in terms of the magnitude and direction, or vice versa. So make sure things make sense. That's what we want to do, is make sense of things. So do it. All right, so let's go ahead and look at another problem where we're doing the converse of this. We are going from unit vector notation into a magnitude and a direction. So here's the problem for that. All right, so we've got ourselves 4 vectors in this case, A hat, B hat, C hat, and D hat. We've got them all written in unit vector notation, right there, bam, conveniently. And we want to represent each of those vectors as a magnitude and direction and draw them out as well, so we can just sort of see things. So I'm going to start with actually drawing these out one by one. We'll do one at a time. So let's stick with A hat here. We have that A hat is equal to 3 I hat plus 5j hat, and we want to write a hat as being equal to some magnitude at some direction relative to the positive x direction. Great. I'm going to draw this out because I got the components. I can draw it out with that. We've got x, we've got y, and we've got this. If I go over 3 units in the positive x direction and then up 5 units in the positive j direction, I should be able to form the total vector here. So we could say 1, 2, 3, 1, 2, 3, 4, 5, and we go like this. There's the x component, there's the y component. This would be 3i hat, 5j hat, which is again a sub x and a sub y, and the total vector goes from where we start, just like that. And there is our a hat that has some angle, theta sub a, and has some magnitude, which is the length of that vector. So this is what we've got. So let's just go ahead and figure out what theta sub a is and the magnitude of a, shall we? Sure. All right, so starting off with the magnitude. The magnitude of a vector is the square root of the sum of the squares of the x and y components, which is just a sub x squared plus a sub y squared, which gives us that the magnitude of a is going to be equal to the square root of 3 squared plus 5 squared, which is what, root 34? And go ahead and evaluate that. .831, we'll call it. 5.831 is the total how much of this vector, and then we've got theta sub a is gotten by the arctangent of a sub y, the y component, over a sub x, the x component, which then gives us arctangent of 5 divided by 3, which is 59.03. 59.036 degrees. All right, what does that leave us with? We've got the magnitude, we've got the direction. Okay, we can write this vector out, right? A hat is then equal to 5.83 at an angle of 59.0 degrees approximately. And what do we look at? We look at this and see if it matches with this within reason. And the answer is yeah. It seems 59 degrees, 60 degrees, sure. Length 5.81, if that's 5 and that's 3, 5.81, that makes sense. There we go. We got it. All right. Let's do it again. Let's do it with this vector b hat. So b hat is 4i hat minus 6j hat. And again, we want to write it as a magnitude and direction. We've got the magnitude of b hat is equal to the square root of the x and y components. So in this case, the y component, we actually call it negative because there's a negative sign out in front of it. It's a negative j hat direction. Ends up not mattering, but we've got 4 quantity squared plus negative 6 quantity squared. So don't put a minus here. The minus goes inside here. Really, we could get rid of it because we're squaring it. It's just to remind us that that is in the negative j hat direction. So with that, we've got that this magnitude of b hat is square root 16 plus 36. Oops. Plus 7.211. 7.211 is the total magnitude, and theta sub b. Let's look at this. Theta sub b is gotten by the arctangent of the y component over the x component. The y component is negative, downward, right? So we've got negative 6 divided by 4. Let's see what this comes out to be. arctangent of negative 6 divided by 4 says negative 56.31, we'll say. Negative 56.31 degrees. All right. So we've got a magnitude and we've got a direction. Let's draw this out. Make sure that things correlate correctly, right? Right. Let's do it. So draw a little representation once again. Purple here. And again, we've got 4 I hat and then minus 6 j hat. So we could go 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, something like that. So we go positive I hat 4, and then negative j hat 6, and the vector goes, the true vector, or total vector if you will, goes from here to the tip there. Go ahead and fix that a little bit. There we go. There's the total vector. This is our b hat. So let's look at something here. Well, what do we got? We've got the angle is stated as a negative angle. Well, is that okay? The answer is yeah, that's okay. Negative angles are just measured clockwise relative to the positive x direction. If you are in this 4th quadrant, generally speaking, your calculator is going to give you a negative angle. It's fine. I like using the negative angle. If you want a positive angle and measure it counterclockwise from the positive x direction, take 360 and add negative 56.31 onto it. And you've got yourself a positive angle. This angle's fine. This angle's fine. This is theta sub b. Negative sign below the positive x-axis. So in the end, everything looks good, and I would just go ahead and say that b hat is equal to 7.21 at negative 56.3 degrees. Seems good, right? All right. So don't be scared of negative angles. Fine. Either's perfectly correct, negative or positive, as long as it's the right corresponding value. Of course, of course. All right, let's do these last two, see what we've got. All right, now we've got c hat. Negative 5 I hat plus 7 j hat. And we want the magnitude direction. Magnitude of c hat is going to be equal to the square root of negative 5 squared plus 7 squared, which square root 49 plus 25 gives us 8.602. There's the magnitude of the vector. Let's look at the angle here. Theta sub c. Well, that again, you can get by looking at the arctangent of the y component over the x component. 7 divided by negative 5. Let's see what happens now. Arctangent of 7 divided by negative 5 gives me another negative angle, negative 54.462. All right, let's see if that's right. Let's make sure that this all matches up within reason. Got our x, got our y. We are going negative x direction, 5 units. 1, 2, 3, 4, 5. And then we are going positive y, 7 units. 1, 2, 3, 4, 5, 6, 7. And come on over here. There's our x component. There's our y component. Throwing a little crooked, but that's what we'll have to do at this point. And there's our total vector there. Here's b hat. Here's theta sub b, or we could measure it again clockwise relative to the positive x direction. But notice something about this. We got ourselves, by mathematically analyzing it, the angle to be negative 54.462 degrees. Well, if we go 54.462 degrees clockwise relative to the x direction, that's down here. That's in the fourth quadrant. This particular vector is pointing into the second quadrant. That's not pointing that way, that's pointing that way. The angle should be somewhere between 180 and 90, right? Not negative 54. That doesn't really do it for us, which would be somewhere in the 280, 290, 295, somewhere around there would be down here. That's not the right angle. So what's wrong here? Did we do something wrong? Mess something up mathematically? The answer is no, we didn't. Your calculator doesn't know the difference. Calculator's not programmed this way. Your calculator is only just taking the ratio of these two numbers, 7 divided by negative 5, and then taking the arctangent of that. It can't tell that it's any different than negative 7 divided by 5. That would be the same quantity, right, as a ratio. Calculator will always put you in either the first or the fourth quadrant. Basically, you can say that it always assumes that the x component is the positive value. And that's pretty much that. So, what can you do with this? Well, it's an easy fix. Because really, negative 54 degrees 4.6 degrees is just 180 degrees off from this. It's just in the opposite direction. The negative sign there's a symmetry, basically. So ultimately, what do we need to do? We need to add 180 degrees onto this. So if we take this angle, negative 54.6, and add 180 degrees onto it, we are then pointing in the true direction of B. It's just like switching 7 to the 5, basically. All right, so say plus 180 degrees. And this is, since our vector actually points into the second quadrant. You're using arctangent to figure out the direction of it, and your vector actually points into the second or the third quadrant, where the x component would be negative, should be negative. Your calculator is going to put you in either the first or the third, and you're going to have to add 180 degrees onto it. How could we catch that? We either catch it by drawing it out and noticing, hey, that's not right, or we notice that the x component's negative. X component's negative, you're going to have to add 180 degrees onto it if you're using arctangent to figure out what the angle is. And that's pretty much that. So what do? We take that numeric value, we just say plus 180. That gives us 125.5. What do we get out of that? Hey, that makes sense. That's 90, 125.5, sure. That looks like our theta sub b. So that's something, again, you've got to be careful of, you've got to be aware. So in the end, we've got ourselves the ability to write out b hat as a magnitude and a direction as 8.60 at an angle of, let's call that just 126 degrees. Yeah, we're supposed to go to even anyway. So 126 degrees. And there we go. There's our b hat. Let's do one last one here, just so we can get all these quadrants. And here we go. So we've got ourselves a d hat is equal to negative 3 I hat minus 8 j hat. We can go ahead and get the magnitude of d hat being equal to the square root of negative 3 squared plus negative 8 squared. Square root of 8.544. So So there's the magnitude of our d hat, and then what do we want? We want the angle. Theta sub d is equal to the arctangent of the y component, -8, divided by the x component, which is -3. So now think about this, right? We just said if the x component's negative, you're going to have to add 180 degrees onto it. We're going to have to add 180 degrees onto this. They're both negative. Well, think about it. -8 divided by -3, that's the same as 8 divided by 3, right? Your calculator just assumes that it's a positive quantity, 8, 3, that's positive x, positive y. That's in the first quadrant. Negative, negative though, negative x, negative y, that's in the third quadrant, which is diametrically opposed. So we're going to have to add 180 degrees onto it, is the bottom line here. Second or third quadrant is your true vector. Have to add 180 degrees. So we've got ourselves 8, 3, which is equal to our 78.69 degrees plus 180 degrees. Oops. Gives us 258.7. 258.7 degrees. Then let's go ahead and draw this out, right? Make sure. Draw it. We've got y, we've got x, we've got -3 and -8. So we go over 3 units, 1, 2, 3, in the negative x direction, then 3 units in the negative y direction. Excuse me, 8 units. 1, 2, 3, 4, 5, 6, 7, 8, somewhere about there. We've got ourselves the components of these vectors, like this. This is a little bit messy, but okay. And drawing the total vector. Here is our d hat. And where's it pointing? It's pointing into the third quadrant, which is where 258.7 degrees resides, right? 90, 180, 270. It's in between 180 and 270. There it is right there. So what is the angle? The angle is this. Theta sub d. If you wanted to call it a negative angle, we could do that. That'd be fine. Take the 258.7 and subtract it from, and subtract 360 from it. Not necessary. Generally speaking, again, negative angles I like to reserve for something that's in the fourth quadrant here. But it's kind of up to you. Negative or positive you could use anywhere. Just have to make sure you're using it right. Ultimately though, we've got ourselves the d hat is 8.54 at, let's call it 259 degrees. That's pretty much that. So we'll be dealing once again with lots of vectors, doing lots of problems with them. So practice, 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 and that'll be that. All right, have a good one.